Okay, so for time's sake, I went ahead and wrote 5.8. So we're told to start with 5.8, and honestly, that makes sense. So 5.8, this is what we're given. F of x is equal to 1 plus x with the limits negative pi to pi. And that's great, lovely, wonderful. But then we're also given f of x 1 plus x is equal to this whole mess, but we don't know bn. So also from the textbook, we have, let's see, we have this. That was our formula that we were given, so I'm going to go ahead and plug in our 1 plus x. And now for time's sake, I will go ahead and write our results. Go with, yes, there we go. Okay, now we can take out, what is that in? Yes. Now, let's see, going back to our original f of x formula. So now that we have our bn, we're going to plug it in right there. However, our bn includes a constant, 2. 2 over, pretend there's a 1 there. So 2 over 1, so we can add that 2 right there. And now we have a negative, that's a positive. So we have 1, that's not supposed to be a 2. I confused my own n's with 2's. That's n, I promise. So we have that. Then we also have, we can't forget our sign. Sign in x. So, that's what it boils down to. Very fun, very cool. Well, now that we have that, we can do like a bit of proof for the series. So like, it's just sine x. And that's different from the rest of them, because the rest of them are going to follow a pattern, which I think is really neat. And half sine 2x. So that's 1/3 sine 3x. So this first one is just going to be sine x because 1 is just 1. But after that, n is equal to 2. That's going to be 1 over whatever the n is times sine of that number again times x. And that's just going to follow the same pattern infinitely, which I think is really neat. 11.7. This we are given, n is equal to, what are you? 1 infinity 1 over n squared. That's great. So we are also given Parseval's, that says Parseval, I promise, theorem. So now that I have that written, basically we can ignore that because the only thing we're using is this. This is what we used. We solved for our b. So using our b, we solved for our all that mess. So now this is what we need here. Now that we have that rewritten, we need the average. We need the average value of the function. So the average value is gonna be what we wrote right here. This is the average value, but we're gonna be plugging in what we have. So let's see. Now we need to take our integral, obviously. So that's gonna be 1 over 6 pi. And then since we powerful, yay, we can do 3, and then have our limits over here. And then going through that whole process, it just gets you, this mess. 1 plus over 3. Yay! That's great. Now that we have the average value, we can go ahead and use that again. After our average value, we can go right on back to, and then we have this -1 over here because I don't know if you remember from previously, we had this negative. So we want to take that out. We put that as a negative over there, and we can move the power into it. Very fun, very cool. And that's a 2. That's squared, I promise. So so from here, we're gonna need, what was it, so we need to, is from our problem, we have a square. So the average of a square for sine or cosine over any period, which is n, is gonna be 1/2. So automatically we can add that. So we already have our 1. I'm gonna erase it up. And then that's 1/2. Yeah? So then we have our rewritten A, and then we can plug in what we had, and then going down here, we can continue to simplify this over and over and over again to our heart's content. So I don't know if you remember the average we got before, the average value of the function. Now we need to set this equal to that as per the rules we established in the beginning. Now that we have that, we can get rid of our 1s. Ooh, we divide everything by 2. That gets rid of our other constant. And now let's see. Dividing by 2 over here is going to be the same as multiplying the denominator by 2, so that just gives us 6. So, and now this, now that we had got rid of the constants, that just looks like our original. Yeah? Now that we know that, we can say that our original is equal to a squared over 6. And this is the sum of our series.